Our discussion of today's topic is magnetic fields and how they destroy superconductivity. In our previous videos, we discussing the experimental approaches based on superconductivity. The link will be provided in the description box. By focusing on the basics of the most important aspect, I hope those videos will be definitely help you. In our substantive discussion, we will discuss experimental approaches to superconductivity. We will discuss the distractions of superconductivity in the today's topics. It is interesting to discuss the experimental threshold curve of the critical field versus temperature. In temperature is calculated in Kelvin scale. We can also measure the critical field in Gauss. What does it mean, Gauss? Gauss is a unit of a magnetic induction equal to a 1/10,000 of a Tesla. So simply how to understand? So Gauss means a unit of a magnetic induction. And what does it mean, Tesla? Tesla means a field of a magnetic, a strength of the magnetic field. So simply from the graph you can see the y-axis scale the calculated in the Gauss. So Gauss means the unit of a magnetic induction, which means to understand magnetic flux density. So that the superconductivity will be destroyed by the sufficiently strong magnetic field. So that the superconductivity is destroyed by the applied magnetic field that have a threshold curve or critical value corresponding to the temperature, which is denoted HCT. HCT is simply is called critical field. Therefore, the critical field at the critical temperature is 0, which means HCTZ equal to 0. As is shown in the figure 3 alongside, the critical field varies with the temperatures from the several conducting elements. So that are from titanium, indium, tin, mercury and lead. Among those 5 different elements, we are going to be discuss about how the separations of the superconducting state in the lower left. How to understand from the lower left is the lower left region, and from the figure from the normal state region in the upper right. So there we are going to be discussed between the two segments. So therefore, from the observation is a common practice of the common superconductivity workers to be denoted BAC as a critical value of a applied magnetic field. As we know the SI unit, we have critical field equal to applied magnetic field divided by permittivity of space or magnetic permeability. An applied magnetic field is represented by the symbol is called BA. Here we can see as a result, we conclude that the definitive approaches of a superconducting this phenomena is to look at a threshold curve that separated. That separated the threshold curve, which means the lower left and upper right is called the superconducting state from the normal state. I hope is that today's discussion helped us gain deep understanding of the topic. I urge you, however, to watch the video once more, share it and subscribe to my channel. It could be very helpful for me if you could provide me with your comments and feedback on our next video. It will be interesting to discuss in the next video in which we discuss the Meissner effect. That is all I have to say. Goodbye.